Doppler's effect in sound. So, what is Doppler effect? The apparent change in the frequency of the source due to a relative motion between source and observer. So, this is what is Doppler's effect. We will see what is the general formula for apparent frequency. Apparent frequency equals to original frequency into V plus or minus VO by V plus or minus Vs. So here V is the speed of sound. So this V is the speed of sound and VO is the speed of observer and Vs is the speed of source. F dash is the apparent frequency, Fo is the original frequency. Now let us see different cases. So we are going to understand the different cases of Doppler's effect. Now let us see the cases, different cases. The first case is this case. If source is moving towards the observer or observer is moving towards the source, or both source and observers are moving towards each other. So what is this case representing? So it is simple. So you please imagine you are the observer here and there is a source of sound which is at a certain distance from you. Now you will hear some sound. Now if I am bringing the source towards you, then you increase the you hear the increased sound. The sound will be more than what you have heard the previous time. So in other case, if you move towards the source, even then you are going to hear the increased sound. Or if both source and observer are moving towards each other, then also you will hear the increased sound. So in this case, if the sound is increased, that means I can say the frequency is increased. So frequency, that is apparent frequency, is greater than the original frequency. So in all these three cases, source is moving towards observer or observer is moving towards the source, or both source and observer are moving towards each other. So in all these three cases, the frequency, the apparent frequency is more than the original frequency. Now let us see what is the formula. We have seen the general formula f dash is equals to Fo into V plus or minus Vo by V plus or minus Vs. So where Vo is the velocity of observer, Vs is the velocity of source, and this V is the velocity of sound. Now, why do we write plus here and why do we write minus here? So this is the point which we have to understand, and it is so simple, you can understand it very easily. So for f dash to be greater than fo, what is one case you have to remember? And here we are multiplying fo with some big term, okay, v plus or minus vo by v plus or minus vs. So we are going to multiply fo with something. That means that this multiplying term should be greater than 1. Only then this f dash will be greater than fo. So please try to understand this very clearly. This term what we are multiplying should be greater than 1. Okay, then only then f dash will be greater than fo, and that is what is the condition which we require. Now see, we write plus in the numerator and we write minus in the denominator. This represent V plus VO by V minus VS. This means, so V is the same. Here also if it is 330, here also it will be 330 only. So 330 plus something in the numerator and 330 minus something in the denominator. So what is representing? The numerator is greater than denominator. So if the numerator is greater than denominator, only then this term FO will be multiplied by that term will result us in the f dash greater than fo. So please try to understand this very carefully. So if we take 330 plus, if velocity of observer is 30, 330 plus 30 will be 360 on the top, and 330 minus 30 will be 300. So 360 by 300, that value is actually greater than 1. So what will be happening? So fo multiplied by a number which is greater than 1. So automatically f dash is greater than fo. So this is the logic which you have to understand. So now let us see all these three cases, how we are working out. Source is moving towards the observer. So this is the source and here it is a stationary observer, and the source is moving towards the stationary observer. Stationary observer in the sense VO, velocity of the observer, is 0 and Vs has some value. Okay. Now for this case, f dash is equals to Fo into V plus 0 by V minus Vs. Why I am writing Vo as 0? Because this observer is stationary. So velocity of observer is 0. Now Fo by V minus Vs. So I have already told why we are writing minus. So if suppose this is 330, suppose V is 330 and by 330 minus 20, definitely what is happening here? Numerator is becoming greater than denominator. So definitely f dash will be greater than fo. So yes, that is what is the sign convention. It is so simple to understand. Just you have to have this knowledge where you are using plus because the frequency, the final frequency is going to be greater than the initial one. So you have to understand that. So it is so simple. That is why we are writing minus here. Okay, now the second condition is observer is moving towards the stationary source. Now the source is stationary, so Vs is becoming 0. And why we are writing plus Vo? Because the frequency has to be, the apparent frequency has to be greater than the original frequency. So for that, V plus Vo by V, so that is 330 plus 30 by V, 330. So that means 360 by 330. Definitely the value is greater than 1. So that is what is we have to understand. The third case, both source and observer are moving towards each other. So this is what I have already told. So if for observer, so observer is in the numerator part, right? So if he is moving towards the observer, sorry, source, then what we have to use? We have to use a plus symbol, because the numerator has to be increased and denominator has to be decreased. So how denominator will be decreased? We are subtracting the Vs, velocity of the source has been subtracted. So that is how we are going to get f dash greater than fo. So in all these three cases, source is moving towards observer or observer is moving towards source, or in this case we should remember one thing, f dash is greater than fo, and we will write the sign depending on that condition. Now we will see the next case, and it is simple. We have already understood that one, so it will be very easy for us to understand this case also. If source is moving away from the observer, or observer is moving away from the source, or both are moving away from each other. So here if I mean from observer, it means a stationary observer. Okay, here it is a stationary source. Okay, now in this case, what is the general formula? It is f dash is greater f dash is equals to fo into v minus vo by v plus vs. Why do we write like this? Because if suppose this is the source and if this is the observer, and if you are moving away from the source, then what is the thing is changed? You're hearing the decreased sound. And if the source is moving away from you, then also you will hear the decreased sound. Or if you both go away from each other, then also you will feel the decreased sound only. So that is the reason the apparent frequency will be lesser than the original frequency. Okay, the apparent frequency is lesser than the original frequency, and this is the condition. You have to know this. Now f dash is equals to fo into v minus vo by v plus vs. So here for f dash to be lesser than fo, we have to make the numerator decreased and denominator increased, so that we can bring this value to lesser than 1, so that f dash is going to be lesser than fo. So I hope you are getting the reason why I am saying that. So we have to make the numerator decreased and denominator increased, so that f dash can be lesser than fo. Now let us see the different cases. Source is moving away from the observer. So now I am taking the source away from the observer. So observer is here stationary and the source is taken away from him. Then f dash is equals to fo into v minus vo. What is vo? He is stationary, so it is 0. V plus Vs. Why we are writing V plus Vs? Because we have to make the denominator increased. If this is 330, then this will be 330 plus 30. If suppose velocity of the source is 30, then it will be 330 by 330 plus 30. So it will be 330 by 360. So that value is lesser than 1. So f dash will be lesser than fo. That is what we want. Now if we take the second case, observer is moving away from the source. Now source is stationary and observer is moving away from the source. Then what is the case? F dash is equals to fo into v minus vo by v plus 0. Why here 0? Because it is vs, velocity of source is 0. What about vo? We have to minus vo from v. Why? Because we have to make the numerator decreased and in denominator increased. So that is the reason. Now if both are moving away from each other, then f dash is equals to fo into v minus vo by v plus vs. and as such it is simple. We are making the numerator decrease and denominator increase, so that we are going to get the apparent value lesser than the original value. And this is all about Doppler's effect, and we will see some more questions so that we are going to get a clear idea of this.